No, I sent you some pictures. Your Gmail.
Hi, Mr. Ray.
Good day. How you doing there, Jacob?
Yes, sir.
Mr. Ray,
Yes.
this is Clemente.
How you doing, Clemente?
You know what? Last Thursday, I didn't come in because I really wasn't feeling that good.
Okay, but
And
thanks for,
I forgot to call to text you and let you know that I wasn't gonna come in. You mean?
oh, thank you
Sorry
for
about that. Sorry about that. You mean?
no, that's fine. I'm glad you told me today.
Okay.
I'm just gonna write that in there. But thank you for letting me know.
Hey,
And let me let someone else in. All right, I'm just gonna say your names. Did you guys see my message in the waiting room?
Yes, we did.
Yes.
Okay, just I was trying to do something for my wife real fast. All right, Jacob, good to see you.
Good to see you too, sir.
Yes, and George, good to see you again.
Hi. Greeting to
And
everyone.
Sergio,
Hi, how you doing?
I'm doing well. Salvador,
Hey, Mr. Ray.
good day. And where am I? Dorcas. Good day,
I'm
Dorcas.
here. Hello.
And Clemente, just writing your name down so I have it down.
thank you.
And William, good day,
Hello.
William.
Hello, Mr. Ray.
Good day. And Marisol, good evening. All right. Having a sneeze. All right. One of those fake sneezes where it feels like you're about to sneeze and nothing happens. All right. So let's go ahead. We're going to continue with where we left off. And remember, I had given you guys an assignment to try that was in the workbook on the inequalities. And that was on page, you have the page, just let me know. I'm looking for it right now.
94.
I think it was page
94 to
94. That
97.
sounds correct. Yes, page 94 onwards. And so if you have any questions regarding that, just let me know and we could go over it. If you don't, I'm going to just assign some questions because the other class had a good bit of questions on there. And some of them, I was glad they brought it up because like we say in the student book, you don't see as many of those type of problems appear. So if you have any questions, just let me know and we can start going through some of them. And I'll just wait a bit just to see if you had any. I know you might not have been able to get to those questions. If not, I totally understand that. But if you have been able to go and you had some questions, feel free now to ask them away. All right, as usual, we don't normally do these ones in order. So I'm gonna start with one of the easier ones. And that would be number 8. So if you look at number 8, that's on page 95. Number 8 is working its way backwards. It gives you a number line and it asks you what the inequality is. So which inequality is shown on the number line? Well, you see that the number line is given. And not so straight, but you get the picture. We have 0 there. And then basically 1, 2, 3, and then -1, -2, -3. And here we have a filled in circle, a closed circle. And think about what that means and then an arrow going in that direction. Okay, so what do the closed circles mean? Does anyone remember?
It means included.
It means you're including, so that's either greater than or equal to or less than or equal to. And then are the numbers smaller or bigger than -1?
Smaller.
Yeah, smaller.
So that means all your possible x values, x meaning any number that you could choose, is going to be less than or equal to -1. And so which choice would that be?
D.
That would be D, that's correct. So D would be the answer there for number 8. But do you remember how to do that? Remember that closed circles mean inclusion. And if you're including something, you want to use the equal sign, and including inside of the inequality. Because all those numbers that are represented by the arrow are less than, you would write it as less than or equal to the number. And I'm just writing down Susanna, who has joined us. All right, any questions on that one?
Yeah, let me ask Mr. Ray. How do we prove that we have the answer number D is correct?
It's literally just following. You choose any number. Is -2 less than -1?
Yeah.
Yeah.
Yeah, so that means it's correct. And is -1 equal to -1?
Yes.
Yes.
Yeah, so you can see right there that that's correct, because any number you choose for x on that side is less than -1.
Okay, okay.
Right, and the solid dot,
Does it mean that from 1 to 2, the difference of 1, then 2 to 3, the difference of 1? Is that so?
It's not because it's a difference of 1. I could have chose -10, let's say later down the line. -10 is less than -1 as well. Even -110. -110 is less than -1. That makes sense. Susanna, we are on page 95, and we're looking at number 8 on the workbook. So in the workbook, page 95, number 8. Does that answer your question, George?
I don't know. Let me say I'm lost, because even though the topic we introduced it last week, was it Thursday? But during the week, I keep on doing the past work, doing the revisions of the past work. So I just introduce myself now on this topic. That's why I'm doubting.
Okay, well, keep watching. Remember, inequalities just mean numbers that are less than. So you don't have to say your age, but you're pretty sure that everyone in high school is under is less than you in terms of age. And I'm pretty sure everyone in a senior home is older than you. And those are examples of inequality. So I don't know your age, you don't have to tell me. Let's just say you are 40 years old. Then everyone in high school is going to be less than your age if you were 40. And if you were at a senior home, everyone would be greater than your age, if that makes sense. That's all inequalities are. Now, if a senior home began at 40, you would include it by putting an equal sign or part of the equal sign underneath it. If high school included 40-year-olds, then you say everyone that is 40 years old and under could be in the high school. And that's literally how we write out the inequalities.
Okay.
All right, hopefully it will make more sense the more questions that we do. And we're going to do a few from the workbook. All right, hopefully anyone else who came in, welcome Gennaro and Susanna.
Hello, Mr. Ray.
Marisol.
Hi, Mr. Ray. Thank you.
You're welcome. We are on page 95, number 8
In the
workbook. Yeah, workbook
95. 95.
All right, and so any other questions that you might have had the opportunity to try and you just weren't too sure? I chose one of the easier ones, number 8, but we're going to try to work our way up to more challenging ones. Let's try number 14. Number 14 is a kind of straightforward one, very similar to number 8. We're going to do number 14 and number 15 here. Number 14 says, complete the inequality that is shown on the number line. Now notice they have X, so that means all you have to do is put the inequality and then the number. You don't actually have to write in X for that one. But number 14 says, complete the inequality that is shown on the number line. I'm just gonna draw that one out. Number line is there. We have -2, -0, 1, 2, 3, etc. That thing goes on forever. All right, so then they have, and remember I draw it above because it's easier for us to see than how the book does it. The book is easier to see what they're doing. Oh, sorry, that's not filled in. It's an open circle there at -1, and then it goes that direction. So how would we write that as an inequality?
So, Mr. Ray,
Yes.
so on that one, would it be like the 1 and then greater than without the equal sign?
That would be correct. X greater and -1 at that. X is greater than -1.
Okay.
So that means all of our values that we could choose would be greater than, but not including, as Salvador said, without the equal sign, because we're not including the -1. So any number that you could think of that's greater than -1 would work. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, even decimal numbers, 2.5, 3.75, right? Any number of that sort would make it work. So for that, but fill in the blank, all you needed was the greater than -1, because they already had the X.
Mr. Ray,
Yes.
is it also because it's not shaded too? If it's
Right.
not shaded, that means you don't have that line.
That line that represents the equal sign, that's correct. Because it's not shaded in, you don't include it. If that was shaded in, a filled in circle, then you would have had that 1. So with that said, what is number 15? Number 15 has, that was much straighter. Number 15.
That one is X is less than or equal to 2.
Okay, that would be correct. I didn't get to finish writing that up, but that is correct.
And Mr. Ray, that's how you say it? So you say X is less than equal to, is that how you say it?
Yeah, less than or equal to.
Less than or equal, okay.
Yeah, so let me write it over here. This one is X is greater than -1. And then this one here, let me draw it out first. This one had a closed circle at 2. And then it goes that direction. So, and then that was correct. This one is X is less than or equal to +2. And the way that it's stated is X is less than or equal to +2 there. So yeah, that's how you say them. X is less than or equal to, X is greater than or equal to, X is less than or equal, sorry, X is less than or X is greater than, based off of the type of question. All right, any other questions for number 14 or number 15?
Yes, Mr. Ray, I have a question.
Sure, go ahead.
Right there on 14, is X is less than -1. I see in the arrow pointing the -1, it doesn't have the line as the number 15. Did that mean anything? Because I missed last class. I have an exam.
Okay, this is Sergio?
Yes.
Okay, so you said, it's the arrows you said that's throwing you off?
Yes, the arrows, I noticed that the 14 X minus equals -1. It doesn't have the line at the bottom as the 15 at the bottom.
Oh, right, that's because it has an open circle. So that open circle means we're not including it.
Okay.
So let me do a quick recap. So remember the inequality signs that we have are this sign here. We read it from left to right. There's a lot of different ways that people teach it. It's literally the signs are created to be, in a sense, based off of what we see every single day. So if you saw something like this in real life, just like kind of balancing on the road, and you were walking next to it or standing next to it, which side takes up more space? Well, it's the side here. This is the bigger side. It's bigger than this side. This is only a point. So when we read it, anything that's on the left side, we say greater than. So that's the bigger side. It's kind of like something that was even, if you shrink something, right? If you have a model of something and then you shrink it down to something tiny, right? It's just like, it's even showing you, it's like pointing down to the smaller side. Other people say stuff like the shark or the Pac-Man eats the bigger number, all sorts of stuff to help you to remember. So the way that one is said, because we read from left to right, going from left to right, when we read, the bigger side is on the left And so that's the part that you would see first if you were reading it. So this is read as greater than.
Okay.
Whereas this side here, if it was going in this direction, maybe this one helps. I'll leave it like that, and hopefully those little hyphens help. So this side, notice the smaller side is over here now, and the bigger side is over here. So when you read that from left to right, that is read as less than.
Okay.
And the next thing is a combination. It's basically we're saying less than or equal to. Now, instead of having to write that out, what people have done is we've combined it together and we make it look like this. Less than with just part of the equal sign. And we call that less than or equal to. And that's the same thing that Salvador was asking about earlier, right? It's the combination of the two, so less than or equal to. And then if it's written this way with the line on the bottom, that is greater than or equal to, because we read from left to right. Oops, greater than or equal to.
Now, what it means equal?
That means that the number could be equal to that, or it could just be greater than. It's either or.
Okay.
So perfect example of all this, and hopefully be a refresher for everyone. I believe I used this analogy last time. If I didn't, then this should help. If we talk about those who can drive, the technical time for the whole nation for when someone can drive is at 16 years old. So if I was to use these same symbols to represent that, those that can drive would be everyone that is 16 or older. So 16 or older means that I include those who are 16 and also those who are older than 16. And that's what that symbol means. Everyone who's greater than or equal to 16. Everyone who's 16 or older. You're including the 16. Those who cannot drive at all on any type of road are those who are strictly less than 16. We don't include the 16-year-olds in this one. It simply means those who are less than 16 years old. Similarly, on a freeway, a 16-year-old cannot drive in a car by themselves. For most states, it's at the age of 18. So for those to drive on the freeway, those are people who are 18 years old or older. And so to represent that, we use the greater than or equal sign to include the 18-year-olds, because they can drive and everyone else who's older than them. And so we say those who are 18 years old or older. The way that we read this is that X is greater than or equal to 18. So anyone who's 18 or older can drive on the freeway. Those who cannot drive on the freeway are those who are strictly less than 18 years old. That means if you are 17 and 11 months, you still cannot drive. You did not make the cut. And so that less than means strictly less than that limit. If you're not 18 yet, you can't drive. Does that make sense?
Yes.
Yep. Now
All
that,
right.
now that's.
All right, so the rest of it, hopefully it will come in as we go. Anything else that needs to be filled in. All right, so now that we've got the basic gist of how they go, let's try number 3 real fast. So number 3 says, which of the following inequalities is shown on the number line? So which one would that be?
Which of the following inequalities is shown on the number line? -3.
X.
So X is the dot, Mr. Ray?
Yeah, X represents the dot and the arrow. It means everything that
Oh, okay.
the dot and the arrow touches.
Okay, now I'm seeing how to read it now.
Okay.
So number 3 should be.
And I heard Dorcas as well. Anyone can say it.
Yeah, X is greater than or equal to negative. Let me have it in my notes. -3. X is greater than or equal to -3.
Okay, do you guys agree with Dorcas on that one?
X is equal to.
Because of the shaded part included, and
Okay,
the arrow is going towards the right.
Okay, I heard yes, and Dorcas is defending herself. She's like, I know I'm right. A
So this is
at
B, right?
That is correct. She is correct. That is X is greater than or equal to -3. She is correct.
B.
Okay,
The
Mr. Ray,
solid,
can
the
I ask a
solid,
question?
hold on real quick. The solid dot includes it. So -3 is included. So you have the line underneath. And all the numbers to the right are greater than 3. So X is greater than or equal to -3. Yes, George.
Okay, we have where we have 0 after then the point of -3, -2, -1. Then where we have 0, could it be the X? Can we replace
No.
X?
X just represents any number that you choose. It could be any number. It could be 0. 0 is greater than -3. Being broke technically is better than being in debt, right? If you had no money versus you owe someone money, you're in a better position.
Because where I'm lost just because I need to find out where we have that X. Since we have
The X just represents any number, all what we've been doing from the very beginning, any number. But in this case, we're seeing that it's in a sense an infinite amount of numbers. Any number that you can think of, any number that you can think of that is greater than or equal to -3 is what X represents.
Okay.
So 15, X can be 15, and that means it's a possible answer, right? Is 15 greater than -3?
Yes.
Yes. How about 27?
Yes.
Yes. How about -2? Is -2 greater than -3?
Yes.
Yeah.
Yes.
Yes.
How about -2.9?
Yes.
Yes.
Yes. -2.957.
Yes.
Yeah, do you get the picture? There are so many possibilities that are greater than -3. And so what we say is just X, it could be anything that is greater than or equal to -3. And that's why it draws an arrow, because there's so many choices. Just like how many age levels can drive over the age of 18 or 18 and older? 18-year-olds, the 18-and-a-half-year-olds, the 18-year-olds and 11-month-old, 19-year-olds, 27, you get the picture? There's so many choices. And so what we do is we say that number, the limit, and everything that's greater than or equal to that, or just greater than. That's what the X represents. Any number that satisfies the statement. Does that make sense?
Yeah.
Yes.
Any number. And that's why it has to be an arrow. So when you draw it on a number line, -3 here, it's saying all these numbers. And the reason why you see an arrow here is to say that that number is going forever. It's including -3. So -3 is included. So it's a solid circle. And then all the numbers that exist forever in that direction. And that's what X is. So X could be -2. X could be right in here, halfway. X could be 1,527, because that's still greater than or equal to -3. So in a sense, there's an infinite amount of choices. And the way that we represent it is the inequality sign. All right, hopefully that helps. I didn't mean to clear that. Okay, any other questions from those who might have tried it? We just went over the basics. All right, let's try number 4. We're gonna do a good bit tonight on this. It's really imperative that you understand it. Actually, I know we're not going in order, so number 5 first. Number 5 says, which of the following inequalities is graphed on a number line using a closed circle? A, B, C, or D? And why?
C.
Okay, that's correct.
It
And
is,
why?
it is C.
That's correct.
Because this C says X is greater or equal.
To -3, and that's correct. With the greater than or greater than or equal to, actually that's the same answer to number 3. That's what it would look like in number 3 if you were to graph it. The greater than or equal to represents a closed circle. The closed circle represents that you are including it. I think I gave it to you guys, this analogy. Remember I said I was trying to rent a car. I was 24 and 364 days old. Literally the next day I was turning 25, and they would not let me rent the car for the lower price that 25-year-olds and older get. And I was begging the guy. I was like, it's like 5 o'clock in like 2 hours. It's gonna be sun, you know, it's like almost new day. Like, please let me get it for like, it was like $200 less. And I was begging, and he was like, nope. The company policy said you must be 25 years older, 25 and older. And I was less than 25. And so I could not get it for the lower rate, right? That's what an inequality is. It's saying that you are not in this range of values. So the X value represents any number. And in my circumstance, I was in this range. The next day, literally the next day, a few hours later, I was in this range. And if I could have waited one more day, which I couldn't, I needed the car for that day, I would have made it into the 25 and older club, right? Just like if you go IHOP and you have that 55 and older club, if you're 54, you cannot get the deals in the 55 and older club. Traditionally, your pension was handed out at 65. So your pension would be those who are 65 and older. If you were to draw that on a number line, it would be those who are 65. You include the 65-year-olds and everyone older than that. Does that make sense?
Yep.
Right, that's what an inequality is. All right, so now what we want to do is take what we know about inequalities and apply them to solving equations. And that's where we're going to start off with number 4 in the workbook still. And it asks us to solve x plus 5 less than 14. Now, if we were to solve this, I don't think we went over how to solve, but basically it's the same exact rules that you use when you're solving an equation. There's only one slightly different rule, and I'll do this over here. I'm gonna call it method 2. Now, for the most part, you can avoid method 2, but it's an important rule to know. So we will solve this regularly, and that is, does anyone remember, how would I solve this? X plus 5 is less than 14.
It could be x5 minus 14.
Say that one more time.
x5 minus 14.
X, how you get, so
No.
what do you mean by X5? Because what happened to the plus sign?
We have to subtract 5 from both sides.
Okay, there we go. We subtract
Minus
5.
minus 5.
Both sides, right? We do the opposite operation. Started with the weaker operation first. That's always the easiest. And technically, both of these operations are the same. They're both addition, and so either one. So you're going to subtract 5, the opposite operation. And what you do to one side, you do to the
Other side.
And so that's correct. So we end up with x is strictly less than 14 subtract 5. And what is 14 subtract 5?
9.
9.
9. And that's your answer. X is less than positive 9. And which answer would that be from number 4?
D.
D. That's correct. Now, they don't ask you this, but sometimes they do. If they ask you to draw this on a number line, I'm skipping numbers, of course. It will look like this, open circle at 9, and then an arrow, so that you're going less than number 9. Right? That's what that would be if you were to sketch it out. Of course, you don't have to sketch, but you would have to choose. So you want to make sure you know the relationship between the open circle and the directions that they can go. All right, now method 2. Method 2 normally comes when you are given a situation. And you can find it in the student book. There's a little rule somewhere, I believe. It should have it in the student book. You should see a statement there about dividing or multiplying by negative numbers. So what page is that? If you open the student book, actually I have the student book here. I could just share it real fast. I'm gonna come back to this in a moment. I'm just gonna reshare so you can see where this important information is. I'm pretty sure, yep, it's right there. I showed it to the other class, but I'm pretty sure I didn't show it to you guys yet. and it's really right here in the last sentence, that if you divide or multiply by a negative number, you have to reverse.
Which page is that, Mr. Ray?
In the student book, this is page 68. So in the student book on page 68, you will see this statement, which I'm about to go, that you've reversed the sign. If and only if, this only happens if you divide both sides of the inequality or multiply both sides of the inequality by a negative number. Now, for the most part, you can avoid this by simply moving the smaller x value. If you move the smaller x value, you typically don't run into this issue. Very seldom you run to it if you make sure you move that. And that's why when we were doing equations, you guys were asking me about which one to move. And I say, I always move the smaller x value first to get away from the negatives. And so I just teach that because it is easier. Now, just to show you what this will look like, if I took this same thing and I decided to go a different way, and I subtracted the x first, and then subtracted x over here, this of course would be much longer, but we would get 5 is less than 14, subtract x. Then if I subtracted 14 from both sides, I would get 5 subtract 14 is negative 9. And then if I wanted to now work out my final answer, I can have a negative x. So if I divided both sides by negative 1 to get rid of that negative, remember the rule says once I divide anything on both sides by a negative number, an inequality, I need to reverse the sign. So negative 9 divided by negative 1 is positive 9. And then we get an x over here. And then the sign would switch. So instead of pointing down to the 9, it will open up to the 9, pointing to the x. Now, these are now the same answer. It's just read backwards. And so if I was to read it going in this direction, it would say the same thing. X is less than 9. The same thing you see here. X is less than 9. And that's the rule. If you divide or multiply by a negative number on both sides of the inequality, you must reverse the sign. The easiest way to stay away from that is just to make sure you keep your x positive. If you keep the x positive, there's no need to worry about this rule. And that's why when you see me do problems and I bring it up like number 10, that's an example where that would happen. You'll always see that I try to keep my x's positive. That way you don't have to worry about the rule. But just in case you forget that, you need to at least remember this rule, that
Mr. Ray, number 7 question is like that.
Yes, number 7 is like that as well.
Number 7. Number
So
7 and number
we can
7
actually
and number 17.
Yeah, 7, number 10, number 17, as you said, and number 16.
And 16.
Yeah, all of those are examples where you could run into that negative aspect. Right? And so let's try number 7. Number 7 says, what is the solution to the inequality 2x plus 3 is greater than or equal to 5x plus 4? And actually, I should have wrote this smaller because I'm going to do both sides so you can see what I mean. So on the first side, I'll just do it the way that I like to do stuff, and that's to stay away from negative numbers. And that's how I've been teaching you guys, is to stay away from negative numbers. That way, once you get here, you don't really have to worry about running into this issue. So if you were to solve this using the same rules, the same steps that we've done in the past when solving equations, where should we start this inequality?
Moving the 2 over to the 5.
All right, and how do we do that?
Subtract 2x and do the same thing to the 5x.
That's correct. And on the left side, that cancels. What are we left with on the left side?
3x.
Just 3. Remember, the x's cancel out.
Oh, okay.
Yeah, just 3. And then what else should we be writing?
Then we'll move
The 4.
Well, we
the 3
bring
over
everything
to the
down,
4.
so we should have 3 greater than or equal to, what's 5x subtract 2x?
3.
3x, and then
Plus 4.
plus 4. Remember, we just bring everything down. When we do that, we're just showing you that we're eliminating stuff. So now this is our new thing, and what do we move now?
Mm,
The
Only-
numbers?
Yeah, well, the numbers, and I want my x to stay positive, so I want to keep that there.
So you,
the 4?
The 4, and how do we move that 4? That's a weaker operation.
Minus 4,
Minus 4?
Minus 4. Remember, you want to go over these rules. It's the same rules every single time. Start with the weaker operation. Do the opposite of that. What you do to one side of the equation or inequality, do to the other side of the equation or the inequality. So 3 subtract 4 is
minus 1.
Minus
minus
1,
1,
-1.
and minus 1 is greater than or equal to 3x. And then one more step we have to do there to get x by itself.
We have to divide the 3.
Divide by 3, and what you do to one side of the inequality, you will do to the other side, and divide this by 3, right? Those 3's cancel, and we have negative 1/3 is greater than or equal to x. Now, if you look down at your choice, you see that the x's are facing another way. You can change it, but you have to make sure you are consistent. Which side is next to the x, the bigger side or the smaller side of this inequality? Which side is next to the x, the pointy side or the bigger open side?
The pointy side.
Pointy side, and the pointy side is smaller. If you were to take a tape measure and measure that thing in real life, which side is the small side?
Yeah.
The pointy side is literally just like real situations, right? It's if you had a roof and I asked you to measure the width of a roof, what side would be the widest part of the roof? The bottom of the roof or the top of the roof?
The bottom.
The longest, which one would be the widest part of the roof?
Oh, widest.
The widest should be the bottom.
The bottom, right? Because the bottom is the part that opens up. The pointy side is the smaller side in terms of width. It's the same thing when we turn it on its side. We used to take this thing and turn it to its side, right? Can I turn this thing to its side? No, I can't. But if I could turn it to its side, basically that thing would disappear. And if I was to turn it to its side, same thing happens. That's the smaller side. This is the bigger side. So big, small. This is really important because if you get something written the opposite direction, you still want to understand what it is. So you have to be consistent here. So which side is the smaller side, the x or the negative third?
The x.
X.
The x is on the smaller side. And so if you were to rewrite it so that x was first, how would you write that sign? With the smaller side still pointing to the x, less than negative third.
X less than equal minus negative 1/3.
All you have to do is say was either negative 1/3 or minus 1/3, not both. But yes, that would be correct if you just said one of them. Negative 1/3 would be fine. So yes, that's correct, right? It's the same thing. We just made sure we rewrote it to look like how it looks in number 7. So when you look at number 7, what's your answer there?
B.
B. Now the other method is the one where you get a negative on the other side. So let's say we had the same thing, 2x plus 3 greater than or equal to 5x plus 4. And we went about solving. And then this time, instead of moving the 2x like I normally have shown you, I decide to move the 5x instead. And I do the opposite operation. And what I do to one side of the inequality, I do to the other. And over here, I get 2x minus 5x is negative 3x. I still have a positive 3 is greater than or equal to 4. Then I continue the process. I move my 3 over by doing the opposite operation. And what I do to one side of the inequality, I do to the other. Those 3's cancel out, and I'm left with negative 3x is greater than or equal to 4 subtract 3 is 1. And then I divide both sides by the number I'm trying to get rid of, which is -3. What I do to one side, I do to the other, excuse me. But I'm dividing by a negative. What happens when we divide it by a negative number?
It changes.
Changes.
The sign changes.
Sign changes. So I need to reverse that sign. And now the sign is pointing the opposite direction, and we still get the same answer. X is less than, excuse me, need some water. X is less than or equal to -1/3. Right? So those are the two different ways. You can avoid the negative sign, or if you do the negative, just remember when you divide by a negative on both sides, reverse the sign. Is that pretty clear?
Let me copy it, sir.
All right, try number 16. I'll leave this up here, and I'm gonna go run and get some water because I keep choking. But go ahead, try number 16. I'll leave this up. Number 16 is on the next page, very similar to this. Try number 16 and see if you could get the correct inequality. You could choose either method to do this. All right, any progress?
Yes.
All right, did you get an answer?
Yes.
I don't know the answer, so hold on. You can send it in the chat.
Where do I click right now?
I sent mine, Mr. Ray.
Okay, I see both of them. All right, I did it in my head. Let me check it one more time. Okay. Since you sent it privately, Salvador, that's correct. And Dorcas, I sent you a message.
Okay. I was trying to send it privately, but I didn't know where to click again.
Oh, so you do you see where it says 2?
2.
Right above where you type your message, it says 2 colon, or you could just click on my name where you saw me respond. You could just click my name.
Okay,
That's one way to do it.
okay, thank you.
You're welcome.
Number 73.
All right, those who have finished, so Dorcas and Salvador, you guys could try number 17.
I hope I got this right.
So
One.
Oh, that's right.
Four times a number is 73. B.
All right, so time is ticking away. I sent in I got a good bit of answers in. So if you got a message back saying you're correct, well done. If not, I'm gonna start the process. Did anyone choose a particular method or did you just go about solving?
I tried doing for the first method.
Okay, stuck with the first.
Let me see where I messed up.
Okay, that's good. If you see where you possibly went wrong. So I'm gonna start number 16 and then see if you have any issues there, you could just let me know with which one. I might do both of them so you can see how both answers can pop out.
I
All right,
sent
so
my
let's,
answer for 17.
okay, you said, oh, I see yours too, Salvador.
Yeah, Mr. Ray, I couldn't put the less or equal, so I just put the less in.
Oh, okay, so it should be a less than or equal to, let's see. Trying to do it in my head real fast. Actually, it should be, you're almost there. I don't see yours, Dorcas. So I'm gonna go ahead and start number 16. 16 says 6x plus x, let me move it over here. So we have 6x plus 2 is greater than 3x subtract 7.
7.
All right, and depending on which method you like, over here on the left, I'm going to start with moving the smaller variable. So we want to move that 3x over, and we do the opposite sign. The opposite sign is subtraction. And what we do to one side of the inequality, we do to the other. All right, so those cancel. We're left with 3x. Bring down the positive 2 is greater than negative 7. Then we want to get the numbers together. Opposite sign of positive 2 is negative 2. What we do to one side of the inequality, we do to the other. That will cause these to cancel, and we're left with just 3x on the left side.
Okay,
Greater than
Negative 9.
negative 9. And then we have one step left, and that would be to divide by
3.
positive 3 on both sides. And we will get x is greater than
-3.
-3. Right, and that's if you do it using the move the smaller, by moving the smaller value, x value that is. If you like to, you don't really care, and you end up with that negative, or you prefer to do the negative route, then that happens when you move the bigger x value. You move the bigger x value, you end up with a negative x value. So those will cancel, and you have 2 is greater than -3x, subtract 7.
Mhm.
When you get your numbers together, so you do the opposite sign, which is addition, and the 7, which you do to one side of the inequality, do to the other. Those 7s cancel, and 2 plus 7 is 9. So you're left with 9 is greater than -3x. All right, and then the last step there is you want to get the x by itself. The operation between -3 and the x is multiplication. So the opposite is to divide by the same number, which includes the negative sign. And what you do to one side of the inequality, you do to the other. Those 3's will cancel. 9 divided by -3 is -3, which is greater than x. If you want to write it back in the proper order, then you put the x first and you follow suit. The pointy side is next to the x, so you rewrite it that way. And you have to make sure you reverse the sign. Actually, let me do that first. Because if I do it all in one step, that's going to throw everybody off. So you have to divide by a negative number, and when you divide by a negative number, it switches the sign. So it ends up pointing this direction. Hold on, I don't have a pen on yet. And I've changed the color so it stands out. So you switch the sign because you divide it by a negative. And then when you rewrite it, the x is next to the bigger side. So you have a greater than, and then -3. So you end up with the exact same answer. So I'll just put here reverse sign. All
Oh, I
right.
see how I did this.
All right. So hopefully that helps. And I'm just going to go
It
ahead.
did.
All right, great. I'm going to go ahead for
It did.
number 17.
I was
Go ahead. You're copying?
no. I was doing it. I thought I was doing it the first method, but I ended up doing using the big variable.
Oh, okay. Right. And that could
I'm
throw
like,
you
where'd I
off.
get stuck? Yeah.
Okay. All right. Anyone else? Did that help? Is it made it a bit clearer?
Yeah.
I stick with the first method.
Yeah, I like the first method first.
All right. First method. Okay. So let's go ahead and try number 17. Can I move on from here? Anyone copying this?
Okay, let me just copy through my phone.
You're taking a picture?
Yes, sir.
Okay, great. Okay, can I start number 17?
Yes.
Yes.
All right, number 17, very similar. It says 4y subtract 2 is less than or equal to 7y plus 10. And this time I'm just going to do one method for time's sake. I'm moving the smaller one to eliminate that divide by a negative thing. So I'm going to move the 4y. And how do I move that 4y over to the right side?
Subtract 4y and do the same thing to the other side.
That's correct. Subtract 4y, do the same to the other side. So over here they cancel, and what would I be left with once I rewrite my inequality?
-2 equal less or equals than 3y plus 10.
That's correct. All right, so we have that inequality, but we need to get y by itself. So what should I move now? What's the weaker operation on the right side to move?
So negative, positive, -10, and then do the same thing on the other side.
Okay, and so we have those negative 10s. We'll cancel on the right side. On the left, what's -2 subtract 10 give us?
-12.
-12, which is less than or equal to 3y. And then we do what? What's that last step?
Divide the 3 by 3, do the same thing on the other side.
All right, and negative 12 divided by a positive 3 is going to give us
-3.
9.
negative,
Negative 4.
negative
Oh,
4. Be
right.
careful there. Yeah, that's negative 4.
Hmm.
And one thing I'm going
That's
to say, on the test, always use your calculator. It's just always safer to just type everything in. I know this from example, especially on tests, you could get a little bit anxious. So we get y is greater than or equal to negative 4 if we read it backwards. So y greater than negative 4, if I wanted to write it, if it was multiple choice and I had to choose, y is greater than, right? Y is on the bigger side. So since y is on the bigger side, if I rewrote it or I turned it around, y will have to be on the bigger side just the same way, negative 4. And so if I have to rewrite it, it's just a quick, just make sure you read it backwards, right? Y is greater than or equal to negative 4. Same answer, it's just basically turned around, like you turn the about face. Okay, so that's how you do the straightforward questions. We're about to now try some of those word questions.
Mr. Ray, I have a question.
Sure.
Let us look to the statement. We have 4y minus 4y minus 2.
Right.
Yeah, but on the other hand, I think that on the left hand, what we do on the left hand goes on the right hand the same. Since we have minus 4 here, where we have y was supposed to be, where we have 7y is supposed to be plus. To me, I was thinking that's supposed to have been plus 4. Do you see it?
No, that's negative 4 because the 4y is positive. We're not looking, this sign here belongs to the 2.
Mm-hmm.
So
Okay.
the
Being
4
positive.
is the positive answer. So because the 4 is positive, you use subtract. Remember, the sign is always on the left side of the number.
Okay, because I have minus 2.
Yeah, a lot of times that throws off a lot of people because they see minus, so they think positive. But that minus belongs to the 2, not the 4.
Okay. That was where my head have problem.
Yeah, so that's a good question. So hopefully that helps anyone else. That's a very popular misconception, is that minus throws people off, so they think plus 4y. So I'm glad you asked that, George. That's a very common question there. So that minus belongs to the 2. Remember when we say, if I say the number 15, I don't have a sign, but I know it's positive, but I don't write the positive there. But if I include a number there, I definitely need the positive, if that makes sense. And same if this is positive 3, if I wanted to see the positive, it's because I include another number in front of it. All right, so great question there. So we're gonna now look at some of the word questions here. Let's start off with number 10. So we're kind of all over the place, but that's fine. Number 10. Number 10 says, and this now tests your ability to take everything you learned from lesson 1 onwards. It asks us when 4 times a number is added to 3, the result is greater than 2 less than 5 times the same number. Which of the following is the inequality? Remember, just like with equations, work with one side first. So what does the first statement says? When 4 times the number
4
is
times
added to
the
3,
number, that means 4x.
right? 4x, and
Plus
then what
3.
else? Plus 3. Then it says is greater than.
Greater than 5x minus 2.
That's correct. Well done, Dorcas. Right? You literally just read it out. 4 times the number plus 3, because that's literally what it says. 4 times the number, that's 4x. Added 2, that's plus 3. Then they say that result is greater than or equal to, right? That's greater than. Sorry, that says just greater than, forgive me. Greater than. 2 less. Remember, 2 less means to subtract 2. And you're subtracting from something. And that something is 5 times the same number. And that same number is x. So if you were to do it in order in which is written, that's 1, 2, 3, 4, 5, 6. Right? So that was the first thing stated. Second thing was stated, third, fourth, fifth, and then sixth. So the first thing stated, 4 times the number. Second thing stated, added 2. The third thing, 3. The fourth thing, greater than. The fifth, 2 less than, remember 2 less than means to subtract 2. 5 less than would mean subtract 5. 18 less than would mean to subtract 18. So that's the 5th part. And then the 6th part and the last 5 times the same number. So that's our answer there. 4x plus 3 greater than 5x subtract 2. And you don't have to solve it. They just wanted you to write it. Which selection is that? A, B, C, or D?
A.
A. That's the correct answer there would be A. All right, did that make sense?
Yeah.
Yes.
All right, that's good. We're kind of skipping around, so we're going to jump over. I'm trying to keep them in kind of order in which they are similar to each other. So let's look at number 22. So number 22 says a store sold 156 football t-shirts. If the store has fewer than, listen to the word fewer than. What does that sound like? Fewer than.
Which question? Which question?
Number
22.
22. If the store has fewer than 34 of the t-shirts left, which expresses how many t-shirts the store had originally in terms of X. So whenever you deal with stuff like this, it's good sometimes to find the total. So it says a store had sold 156 football t-shirts. And then it says the store has fewer than. What would that mean? The store has fewer than 34. How could you write that? Fewer than 34.
Less than 34.
Less than 34, right? So we know that the store has that many left. It said they originally had X amount of shirts. That's the last part, right? X amount of shirts. How many did they sell?
Um,
156.
156. So that means they are 156 less than their original amount. How could I write that? 156 less than what I originally had.
No, the 156 less than.
So let's put it this way. Sometimes using real numbers help. If I originally had 300 shirts and I sold 156, how can I show that mathematically to see how many I left?
you subtract.
You subtract. So what would I do here?
Sure.
So
Subtract 34 from 156.
No, 156 from X. Remember they said
Oh,
X.
sorry.
oh, so we're gonna add it.
X was the original amount according to the question.
Okay.
So we add 156.
Right, so at the end, we're going to be adding. Now remember, we're subtracting because that's how much we sold. We don't have it anymore. We're taking away
Okay.
156 from X, and X represent what we originally had. But we're trying to figure out what did we originally have, if that makes sense.
Okay.
So yes, we're going to now add, as Dorcas said, 156. We're going to do the opposite operation. Same number. What we do to one side of the inequality, do to the other. So that leaves us with X is less than, what's 156 plus 34?
190.
190. So we end up with X is less than 190. So what would that answer be?
That would be D.
That's choice D. All right, hopefully all of this is making sense the more that you see it. We're not going to do every single one, but we are going to do a good bit. And with the other class, we went up until about the equivalent of 7:30. So we're going to do the same here to about 7:30. All right. With that, let's do one that's similar to that one. I know we're all over the place, but it's just because I'm trying to keep them consistent. Number 13. So number 13, back to page 95. Number 13 says Dylan bowled 2 games and got scores. Actually, this one's a little bit more challenging. Hold on. I'll save that one for last. All right, so we're going to finish off with number 29 and then 1 and 2, and then 13 and 32. So that's the plan. I think we could get them all done in that time frame. So 29 and then 1 and 2, number 13, and then number 32. And if we do that, we would do almost the exact same amount as the other class. You would have done one more. All right, so number 29 first on page 97. And the ones that we don't do, although we have a break this week, you want to try to review them at least on Sunday. I know it's Thanksgiving. I'm not American, my wife is. So, you know, I'm not that gung-ho about Thanksgiving yet. But if you aren't, then use that time to review. If you're a big-time American Thanksgiving person, then Sunday you want to start getting back into the swing of things. So number 29 says, Elena is taking a bus to visit a friend and is going to buy some reading material for the trip. She has $15 to spend and would like to buy one magazine and one book. The book costs $8.99. The sales tax is 6% of the purchase price. Which inequality represents the maximum price of a magazine that she could buy? All right, that one's really wordy, and so you really want to try to break it down. The first sentence is not really important in terms of solving the equation inequality. So it really is the second question. And the key to inequalities, one of the best ways to start is to look for the totals and the inequality. So you're looking for the statement and the total. What is the statement that tells you the type of inequality? And then what is the total? So do you see a total there?
No. Oh, yeah.
What are we doing?
Number 29.
Oh, 29.
Well, she has $15.
She has $15. So think about this. If she only has $15 to spend, what inequality would best represent that?
Less than.
Eight? Oh.
Less than. Well, it's going to be hard.
Yeah.
I'll give you guys this much. If you could choose the question just by looking, you are really, really brilliant. So we're going to have to work this one out. So this one is less than 15. That's correct, Dorcas. She can't spend, and not just less than, can she spend $15?
No. Less than or equal.
Could she spend all her money?
Yeah.
Definitely she
Yeah,
can spend, but not more than that
Yeah.
amount.
Yeah, she can't go over 15, right? But she could spend $15 and she could spend less than 15, but she
15.
can't go over that. So the inequality that would represent that would be less than or equal to 15. Does that make sense?
Yes.
Right, she can't spend more. She can't spend $15 and a penny. She only has $15. So if it came up to $15, she could pay it. And so therefore you have to use the equal one as well. And she could spend 14 and 13 and 12 and 10.95, etc. So anything less than or equal to 15, she could spend. Does that make sense?
Yes.
Yes.
All right, the next thing is very similar to what we've done before. What is she buying?
A book.
She's buying a magazine.
Magazine
Book
and
of
a
the
book.
magazine.
One book, yes.
And remember, I told you, if you write it out in words, it really helps you out. We did that with the Republican pins and the Democrat pins, and with other things, we were writing it out in words. So we know she's spending money on the price of the magazine, however that much costs, and just put a $ there. So the cost of the magazine plus the cost, that $ represents the cost of the book, has to be less than or equal to 15. Does that make sense?
Yeah.
Yes.
Yeah, so whatever she's buying, it's only two things, a magazine and a book, and it can be either $15 altogether or strictly less than $15. Now, there's another thing added there, though, and this is real life situation. Say that again?
Taxes.
Taxes, right? Nowhere in the U.S. can, except for certain states, I think Arizona, New Jersey, but not in California. Not in California where you could buy something in a store and not pay taxes. So now we need to put the tax part in there. And do we pay taxes just on the magazine?
No.
On the book too.
Just on the book?
Both.
No.
Both. How did we learn to show both mathematically? What did we put?
X
That's
2.
no X variable.
No, how do we show that we're putting everything into one group?
Oh, parentheses.
Parentheses, right? We want to use parentheses here. that shows us that the purchase price, we're going to pay a tax on whatever that price is. Now, what is the tax that we're paying on this?
6%.
6%.
6%. Does anyone remember the shortcut that I showed you, how you can show 6% tax versus 5% sale?
It could be 0.06.
Show it again.
Okay, that's the first step. It's going to be, let me write it out. So we're going to have our tax times the purchase amount, right? That's basically what we have. Our tax times the purchase amount has to be less than or equal to 15. So now that we have our verbal model, you're on the right track there, George. We know that 6% represents 0.06, but did you learn it? Did I teach you? I did teach it to you. Do you remember another way to write that to show the 6% increase that you have to pay?
I think it would be 106%.
Well done. That's correct. It's 106%. I don't know if you guys remember that. I said to you guys that 100%, you know, like if you're not feeling well and someone asks you, how do you feel today? And you might say, I feel 100%. And then another day you might be like, I feel like 80%. I don't feel too well, right? 100% means the actual amount. Now, if I add tax to it, that's 106%. And you can literally do this in the store. Now, how do we write 106% in terms of a decimal?
Oh,
Is it 0.0?
1.06.
1.06. Remember, we spent a week on that doing decimals and percentages. 1.06. So now we just need to start replacing everything. Now, although this may look long, it can be done shortly if you practice this. We've done this in like lesson 6, I think it is. We practice doing stuff like this. So we have our tax. Our tax is 1.06. And that's literally how you do tax. If you go to the store, like literally if you went to the store tonight, I think tax on average is about 8% in California. It's like 7.75, but let's just say 8%. If you did 1.08 times whatever your cost is, you'll find out your total amount with the tax. Same thing with the sale. The sale is you're doing less than 100%. So Black Friday is coming up. You're going to have all these sales. If you have a 30% off sale, 30% off of 100 is 70%, which means you're only paying 70% of the price. And that shows a deduction, a reduction. And so that's how you actually do it really fast, and you can work out your cost. So the same thing here. I'm going to take 1.06, my tax, and times it by the cost of the magazine plus the cost of the book. But now we have to write that out. And how would we write out the cost of the magazine and the book? Well, we need to look back in there.
$8.99, $8.99.
Okay, so it says the book costs how much?
$8.99.
$8.99. And how about the magazine? How much does that cost?
Doesn't say.
Doesn't say. So what could we put for that?
X.
X. And we're basically done. Do you see that anywhere?
Yes.
Which one?
D.
D. That's your answer. All right, and if you want to play around with that one, make sure you can own it and understand it. It is very similar. I don't know if you guys have noticed, but a lot of the questions are very, very similar in their style. And if you can master that verbal concept and then just replace it afterwards, then you can start getting more and more correct answers there. All right, does that help for number 29?
The answer was D.
Yes, D.
Okay.
That because we're basically done. Now you can see that could literally take less than a minute to do that. You just, if you can read the question and just think about it like real life. I have a magazine plus a book, and I can't spend more than $15. So that's less than or equal to 15. And then I have to pay tax on that. So that's tax times my purchase price less than or equal to 15. What's the tax? 6%. Oh, that's 1.06, right? If you have a tax of 10%, it's 1.10. If it's a tax of 3%, 1.03. And you can literally do that in real life. Like you can literally go to the store and just do that and find your cost. But that's the answer for D. Now we're going to skip over to number 1 and number 2. Any questions though with that one?
No, it's good.
Okay, good. All right, number 1 and number 2. I know we're all over the place, but like I said, I'm trying to keep the style of the questions together because they just mix them up. But at least you can see it going from easy to more challenging. So number 1 says Alex is using a rectangular piece of plywood to build a workbench. So if I was to draw a rectangular piece of plywood here, I'm trying to make it the color of plywood. So he has this rectangular piece of plywood. It says he wants the area of the workbench to be at least 100 feet. Now that part they wrote out for you. They said that his area needs to be at least 100 square feet. Remember the word at least means the lowest or
Not
the
above.
smallest he wants it to be is 100 square feet. So that means it has to be 100 or more. And so that's why area is greater than or equal to 100. All right?
Yeah.
Then they tell you that the length is 25 feet. So then question number 1 says, which inequality could be solved to find the minimum width of the plywood? Well, first of all, think about what is the area of a rectangle equal to?
Length times width.
Length
Right.
times width. What are we missing here in this diagram?
Width.
Width. And what could I represent width to be?
It could be X.
X or anything. Any
Well,
variable.
in this case, and if you look at number 1, what variable did they use?
The W for width.
The width.
W for width. All right, so if I was to write this out, what would my area be if I have 25 and W?
25 W.
Less than.
So 25W is literally what my area is. Does that make sense?
Yeah.
Yeah.
So I could replace area with 25W, which is greater than or equal to 100. And I'm done. What answer would that be?
That would be
Mr. Ray.
That would be D. That's correct.
Mr.
Yes.
Ray, let me ask, how could it be D? Because the D shows greater than. Is that not greater than? That sign is greater than.
Yeah, it's the same sign that's in the book.
I was thinking that the error could not be above 100.
Yeah, what it's saying that the area is. It says that the where is it? At least. When you use the word at least, that means the lowest that I want my area.
Okay.
100. So that means if my lowest is 100, it could be 101, 102, 110, 150, etc.
That's why I had that mistake. I was thinking that it could just be just around 100 below, not. But the statement says that from 100 and above.
Right.
Okay.
Right.
Okay.
So
Okay.
you want to get those
But
words down.
you're
Now,
right,
anyone who's trying to be like it depends on what type of position, but if you want to get one of those positions like a managerial position, as like a contractor, if you're working like say Home Depot, managerial position where you're ordering things, inequalities is a big thing there. So anyone who works in a warehouse, whoever does most of the ordering has to have an understanding of inequalities because you have to think about your minimums, your maximums, what's the lowest that you could possibly get, highest profit, right? So that's what they're doing constantly, is calculations such as that.
Mr.
All right,
Ray.
number 2. Somebody call me?
Yeah, I'm sorry, it's me. Sorry, you only take a second.
Sure.
So like A, perhaps let's say A 25 minus W is less than, that wouldn't be the answer. So just by looking at the answers, we can actually find the answer, right? By 25W is.
Yeah, because once you realize that it's area is multiplication. And so you could have crossed out A and B because those are addition. And you know it has to be multiplication. And so A and B could have been crossed out.
And it has to be greater than 100. So there you go with the rest of it, huh?
Right. So that's how we get the D because it has to be in accordance with the statement.
At least or greater. So that'd be okay.
Yeah. So at least means the smallest that it can be. So you got to be careful with those ones because when we hear at least, we naturally think less than. But at least means if I said, if somebody said, how much money do you want? I'm like, I want at least $100. Do I want less than 100 or more than 100?
More than
100.
more
More.
than
Now notice, as soon as I put money in there, you knew what the answer was. Remember I said that to you? If you replace whatever you're doing with money, normally it makes sense right away. I mean, it's just, that's how I start to make sense of math. I start to make sense with money. Like, oh, if it's money, I know what the answer is, like, right away. When it's not money, I'm like, oh, man, what was it? But the moment you replace it with a money example, it's just like, oh, eureka, makes sense. Right? So if you get stuck on the test, try to do that. You know, what if this was money? And I use the same phrase. Oh, okay, right? So you want that freedom as well. All right, let's try number 2. Number 2 continues right on from this. It asks you to solve this equation, inequality. So how would you solve this inequality?
You just divide it by 25.
That's correct. You divide both sides by 25. All right, but what would that give us?
4.
That will give
Four.
us
4.
Greater than.
But what would be the symbol?
What W?
W greater than or equals to 4.
4. All right, and what choice is that
C.
for number 2?
C.
B.
That would be C.
C.
That one's C. Be careful with that one.
Yeah.
You want to make sure you have the same direction and everything. So that one would be C. All right, we're a little bit behind than what I wanted, and we have 2 questions left, and I think we should be able to do them at least in a few minutes. So that's number 13, and then number 32. Now, number 13 and 32 are stuff that we haven't quite done. You might have, some of you might have a basic idea, and let's just go ahead and read it. Number 13 says, Dylan bowled 2 games and got scores of 122 and 118. Now, this is a real life example. It says he wants to bowl 1 more game and end up with an average of at least 124. Which inequality represents the score X that Dylan needs to get an average score of at least 124? Now, average, we haven't done averages yet. I skipped over it. But if you want to know more about what averages are, you can find that in the student book on page 30 and 31. Now, another name for average is mean. So if you are wondering what the mean is, M-E-A-N, that's the same as average if you want to read up on it. But I'm going to just show it anyhow. An example of what an average is, if I was saying let's say I don't know, I'm trying to think of something.
Does it mean that you add up and then divide by the quantity?
Right, that's what an average is. An average is simply you add up the terms that you have. So add all your terms or not values, add all the values and divide by the amount of values. So add all the values, then divide by the number or amount of values. So for instance, if I had 6, let's just say it's a soccer game, right? In the soccer game with children, they score a lot of goals. So the first game they have 6, the second game 3, the third game 5, and the last game 2. To find the average, you would add them all up and divide by, does anyone know? By 4. You divide by 4 because that represents the 4 games, right? So the values, you add them up, divide by 4, and that gives you the average value. And in this case, 6 plus 3 is 9, 14, 16. Oh, that's great. 16 divided by 4 gives us 4.
It's
So
4.
the average amount of goals scored in their game would be 4, right? You hear that in almost all sports. If you're listening to basketball, they're talking about 3-point average. They're talking about free throw averages. That's how they find the averages, right? They just simply add up whatever values are there and then divide by the amount of values. So on average, this team scores about 4 goals a game, right? So that's what an average is. So we're going to use that example to do number 13. And so for this one, it says Dylan bowled 2 games. His first game, he got 122. And the second, he got 118. So you're going to add those up. Now, this happens in real life situations. And this one says he wants to bowl one more game. Do we know what he's going to get in that last game?
No, we
No,
do
we
No.
not. But
What could we represent that to be?
X.
X. So in his third game, he's trying to figure out what he's going to get. And it says he wants to get at least a 124. So his average, he wants his average for the 3 games to be 124. And he's trying to figure out, how can I get my average up to 124? What score would I need? Well, what would he have to divide by, first off, if he has 3 games?
You divide by 3.
You have
124.
to divide by 3.
Okay.
Now we need to know what inequality would represent this. He wants to get at least 124.
Greater than or equal to.
That's correct. Greater than or equal to. He doesn't want any less than 124. He wants to make it to at least 124. Let's say his friend made 123, and he's like, I got to make 124 or higher, right? That's what at least means. I think money. I need at least $124, right? That means greater than or equal to. Now we have our nice little inequality, and we could go about solving it. How do we go about solving? Same exact steps as equations. Remember, simplify, then solve. So how would I simplify this?
We add up 122 plus 118.
That's correct. We're going to add those 2 together. What would that give?
240.
240.
That'll give us 240 plus x divided by 3 is greater than or equal to 124. Then we need to keep on solving. What would we do next?
Let's see. I think we'll multiply both, the fraction by 3.
Yeah, we're going to multiply by 3 because that division sign is creating a quantity. So you got to get rid of the division first.
Yeah.
And what we do to one side, we do to the other. So these cancel.
And then that cancel.
So 240 plus x is greater than or equal to 3 times 124. You could do that on a calculator or work it out on the side.
That's
3 times 4
12.
is 12. Carry the 1. 3 times 2, 6, 7. So 372. That's correct. I heard. Now we have one more step to solve. What would that be?
We divide both
Not
sides
divide.
by 240.
Not divide.
We subtract.
Subtract. We're subtracting
Okay,
by
subtracting. Oh yeah, that's true.
Yeah. Be careful of those ones. And what we do to one side, do to the other. So we're going to have x is greater than or equal to, what's 372 subtract 240?
132.
132. And what would be our selection there?
A.
A.
Yeah.
So A would be the answer for number 13.
Mr. Ray, let me put it another way around. Whether you agree with me. You get me? You got me?
Go ahead, quick.
Okay. I believe that we have 240 plus x. So the weaker side is following up the laws of equation, which is addition, subtraction, multiplication up to parentheses. So I was thinking that we need to take the 240 add to subtract from 124.
So remember,
first.
I'm just for time's sake, I'm just gonna remind you. Remember, I said we treat anything that has a quantity over 3, we treat it like it's one item. So we'll treat that like it's greater than or equal to 124, like this is one entity. And because that's one entity, we would actually do it last. It's a stronger operation, and so we do the weaker operation first, which is division. Does that make sense?
Okay.
Using the order of operations, we do the quantity last. If we do the order of operations backwards. All right. All right, we have, now just to help you out, if you want to do ones like number 13, number 21 is very similar to number 13. And also there's another one, I don't remember which one it was. Oh, number 28. So number 21 and number 28 is very similar to number 13 and number 32, and we're about to do number 32 right now. So once again, number 13, 21, 28, and number 32 are all similar. They all deal with averages. But we're gonna do number 13 and 32. You guys can always try number 21 and number 28 on your own. So number 32, that's what we're doing now. Number 32 is the last question, I believe. It says, in an English class, students must earn an average score of 80% or above on their written. So 80% or above. If I was to write an inequality, which inequality represents 80% or above?
Greater than?
Greater than. But if I'm including the 80, what else do I need? Greater than or equal to. Right? So I know I at least have greater than or equal to 80, because I have to have 80% or higher. It then says, Leah's scores on her first 4 papers are shown below. Paper 1, she got 78, paper 2, etc. It says, what is the minimum score Leah needs on her 5th and final paper to earn a B in the class? Now remember, it started off telling us these are her averages. She wants an average score of 80 or higher. Remember, to find an average, we add up all her scores. So we have 78 plus
85,
85 plus
82,
82,
plus
74.
74 plus
X.
X, right? I'm gonna have to move this over some. I don't have enough room for the X. All right, and then plus X is correct because we don't know what that last item is. What do we divide it by?
By 5.
By 5, because we include that X. We don't know what it is yet. We're
I
gonna
was gonna
find
say
it.
4.
All right, and so now how do I go about solving that? First step, simplify. So I need to add all of these
Add
items up.
everything up.
So what would be those numbers if I add them all up together? I think that's like 319, I believe. Yeah, I think that's it. 319 plus X.
Yeah, 319.
Okay, thanks for the
319 per
confirmation.
6.
So 319 plus X divided by 5 is greater than or equal to 80. And just like the one we did in number 13, what would be our next step?
We'll multiply by 5.
Multiply by 5 on both sides. Okay, and so that gives us 319 plus X is greater than or equal to 5 times 80 is 400, I believe. Yes, 400. All right, one last step to do. I need to solve for X, and how do I do that?
You subtract 319 from both sides.
Subtract 319 from both sides. That's correct. All right, and so we're going to have X is greater than or equal to, what is 400 subtract 319?
Mr. Where do we get the 400?
5 times 80.
5 times 80, okay.
And what's 300 subtract, sorry, what's 400 subtract 319?
81.
81.
81. So X has to be greater than or equal to 81. All right, I'm trying to decide, should I start? So yeah, you want to do all the ones that I skipped. So anything I skipped, you want to work on that between, we're missing Thursday, remember. So I try to do a lot of inequalities because inequalities, believe it or not, is one of the most used elements in mathematics because you use it normally in anything dealing with production. It is used heavily in production, and that's how we ship things all over the world. You got to deal with estimations, losses and profits, and what happens if we lose them all. All right, what is the least amount that we can lose? What's the most that we can sell, right? That's inequalities. And if you want to get those higher positions, you have to understand inequalities. So make sure as much as you can, you got to really force yourself to your willpower to say, all right, let me finish the ones we didn't do. I don't remember exactly, but if you have been numbering them, hopefully that will help. If not, doing them again doesn't hurt if you did all 32 over again. So we're going to stop there with inequalities. Any other questions you may have, just make sure you bring them next week, Tuesday, as Thursday is Thanksgiving. So I did want to at least introduce you to the next lesson. And so we're going to go back to the student book. We're done with, excuse me, inequalities for now. Make sure you practice as much as you can. And we're going to at least start with, excuse me, the coordinate grid. Getting hiccups. Excuse me. All right, so we have here the coordinate grid. This is
What page
lesson
is that,
11.
Victor?
I'm on the student book on page 70. Now, the coordinate grid has its connection to the tables that we were doing. Remember when we were doing sequences and progressions, and we were looking at the tables? Well, they are directly connected to the coordinate grid. It's literally how we graph, right? The X and the Y's, they were called our ordered pairs. And so here's an example. The ordered pair there would be 3, 2. Because when we write them as an ordered pair, we write it as X, Y, which represents the same elements from the table. Now, the reason why it's called an ordered pair is because they are in alphabetical order, and it's 2 of them. So it's basically 2 values that are in order. And the order is X, Y, because X comes before Y, right? X, Y, Z, W, X, Y, Z. So that's why it's called an ordered pair. And that X, Y that we were using from the table, whether it was using sequences or the table, represent those variables. Now, the coordinate grid is how we actually graph them, so we can visually see what we're dealing with. So when we had those coordinate tables, we could take that coordinate table and then graph them physically on a graph. So that's what a coordinate grid is. Now, a coordinate grid is used in many different things. So maps, back before Google Earth took over, and maps and stuff on your phone, you might remember you might have had to download MapQuest directions and a map, right? And you had a road map, and you literally had all these different lines on there. Those were coordinate grids. You may remember latitude and longitudes. If you're in my social studies class, you learn about latitude and longitude. It works the exact same way, the coordinate grid. And so hopefully I'm trying to bridge your experiences to the use of this. Now, when we deal with it in math, the horizontal line, we call it the x-axis. That's where anything that's on the first part, anything that's on the x table, anything on the x table, that represents those numbers. So they will be on the horizontal line. You're not sure what horizontal means? In there, you see the word horizon. Horizon is when you look straight out. The y-axis is where you put all the y values, and that's the vertical line. If you like basketball, you might hear people talk about a 40-inch vertical. It means how high can you jump, right? So the vertical line is the y-axis. And when these lines cross, they create the coordinate grid. And it's fairly easy to use once you get used to it. The middle of the coordinate grid, we call that the origin. It's where you get the word original, originate, etc. It just means the starting point. And the starting point for both the x and the y is 0, 0. X is 0, y is 0. And just like we learned with integers, you can end up in the negative realm. No problem, Sergio, if you can still hear me. All right, and so the way that the x values work, we count how many spaces we move to the right. If we go to the right, it's positive. If we go to the left, it's negative. For the y-axis, if we go up, it's positive. If we go down, it's negative. You may remember at the very beginning of integers, I had drew a person who was supposed to be like on the water, and they were like swimming. And I said they're swimming on top of the water, right? They're up here swimming. And fish are swimming below the water, means they're -2. And birds may be flying above the water. Could be 5 meters above the water. He's swimming right on the water. The fish is 2 meters below him, right? That's an example of the coordinate grid. It's just showing you direction. And over here, a boat could be a few meters behind him, sailing behind him, right? And so we see above, on, and below. It can represent a stock market chart, right? If you look at the stocks, do you see the charts are moving over time? And so the x-axis could represent time, and the chart represents profits and losses. It could represent a map. You're here on your car, you're trying to get to point C, and you're trying to see what directions you need to go to get there. That's an example of a coordinate grid. And so first things first, we need to know how to read these coordinate grids. And a coordinate grid is split up into 4 quadrants. The way that we number those 4 quadrants, and you see that right here, the way that these 4 quadrants that are divided are numbered are in an anti-clockwise direction or counterclockwise direction. So a clock normally goes to the right. When you count the quadrants, you go to the left. And so if I was to write out what these quadrants are, let me just do that real fast. This would be quadrant 1. Quadrant 2 is over here. We call that the second quadrant. This is the third quadrant, and this is using Roman numerals. And then this one is the 4th quadrant. And so we count in a counterclockwise direction. Now here comes the part that can be considered easy or not. But you just want to make sure you know that's 1st, 2nd, 3rd, 4th in that order. And we'll get to more of it when we come back. But what I really want to get to is just to make sure you get an understanding of how to graph these points. So for instance, this point C, that's number 1. Number 1 axis, what are the coordinates of point C? Well, remember, the way that you read it is X first, because it's in order, then Y. Remember, the x-axis is on the horizontal. So where is C located in terms of the x-axis? Well, you could just look down, imaginary line that you could draw, and your x-axis is at 2. Did I hear the answer?
Yeah, it's on 2, and it goes up.
Right, and on the y-axis, where is it located? In connection to the y?
2.
2 as well.
And so that's my coordinate point, 2, 2. That's the coordinate point for C. And so for that one, what would your answer be for number 1?
No, it's A.
The answer would be A. All right, let's try the other ones real fast.
Mr. Ray, excuse me, where is the 2 for the y? I've not seen the position of 2.
Say that again?
The position where we have 2 for y.
It's right here, 2. On the y-axis is 2, and on the x-axis is 2.
Okay.
All right, how about point A? That will be a little bit more challenging. What would point A be? Where is it on the x-axis? What position?
1.
That would be -1.
That's correct. On the x-axis, -1. How about the y-axis? Think carefully.
Y-axis is, let's see, is positive
0.
1.
It's 0. Well done. That's 0.
What?
That's at 0, right? Because the y-axis represents your vertical and above and below.
Oh, yeah, that's true.
If you think of this as walking on the ground, and this is people that are on the ground on the subway, then A is right on the ground, which will represent 0, ground level, right? Even the elevators have it. Ground level is 0. Then the next floor is the first floor, right? So your y is 0. So that's your point, -1, 0. And all that represents is that you have gone one unit to the left, and you haven't gone up in the air. You're still right on the ground. How about point B? What would point B? What would that point be?
5.
Okay, that's part of it. What's the x? Remember x first.
1 is -5.
-1, -5.
Right, that's correct. -1, -5. Is that my computer or somebody else's computer making noise?
I don't know. I hear it too.
Yeah, I'm like, first I thought it was my fire alarm.
Mr. Ray, please, I'm still lost. Okay, which one are we talking? Is it B? Is it
B,
point B?
right here, the one I'm writing on, B.
Okay, then where do we have the -1, the negative for the part for B?
Because we're looking at the x-axis first. Remember, it's x, y. So it's x, comma, y.
Yeah, I've seen the B, but where is the position of y on the vertical line? I've not seen it.
You said -1, so.
Say that again?
Where is the position of 1, the position of B in the vertical line?
It's -5 right here.
-5. Okay.
Or if you think of this as just like real life, like how far has B fallen from below the ground? Like if this was water and each line represented how far down you went, where is B? B is literally 5 meters below sea level, right? And if you think of the 0 as just being where the boat's located, I say the boat's here, it's just saying, look, B is 1 unit behind the boat and 5 units down below the boat. That's all you're saying. So B is literally -1 unit over, 5 units down. All right, how about D? How would we say the point D?
-2 and
Three.
-3.
Not -3,
+3.
Oh, my
positive
bad.
3.
That's 3.
Right.
That's 3.
Yeah, be careful there, but I knew what you meant. +3 because you're above. And once again, if you think of this as like, this is the ground or sea level, think of this as a bird flying in the air. And think of this as the boat is at the origin. The bird is 2 units behind the boat, -2. And then the bird's flying 3 units above the boat. Does that make sense?
Yeah, Mr. Ray, is it the
Yeah.
one we do rise over run or not this
We're
one?
getting there. We're not there yet, but we're making our way there.
Oh,
Before you could do any rise over run, you have to know how to read the points. So we're making our way to how to do rise over run and the equations of a line and all that. All right, so we have the point 2, 3 for D. Any -2, sorry, -2, 3. All right, we're gonna try one more that's over at the next page. And over here, what we see is says to plot the point 5, -3. Now, I know it might be tempting to do this in the book. So if you have a book that is not yours, you need to do it in pencil and you need to do it as light as you can if that's your plan. So that if it's erased, you won't even see it. Because remember, these are the school's books if you have them. So in order to plot this point, so my recommendation is not to do it, but if you are going to do it anyway, please do it as lightly as you can with pencil and then erase it. So you can take a picture of it or something. If I wanted to plot the point 5, -3, well, first I'll go on the x-axis to 5,
yes.
then to the y-axis -3. On the x-axis, 5 is here. That's where 5 is.
Yeah.
And then on the y-axis, -3 is here. And I want to see where they meet. And where they meet is my point 5, -3. Oh, that's not 5. Forgive me.
Yeah, 5 should be on your
5 down
yeah.
here. Yeah, so there we go. So that's the point, 5, -3. All right, so that's how you can find the points. You can use the coordinate grids to help you. Now, the next one asks you to translate the point. The word translate is literally that. It means to change something. So when you translate a language, you change from one language to another. But in this case, you're going to change the point
Mr. Ray.
up 6 units.
You have a
Yes.
5 and 5. Too?
Mr. Ray.
Yes, Salvador?
Yeah, you got 5 and 5. So shouldn't it be +5 and then -3?
Thank you. Yeah, that's what happens when you're Russian. Thank you. I was right the first time. I don't know what happened. 5, -3.
Yeah.
I had it right the first time. I don't know why I changed it. So yeah, that was 5, -3. Well done, Salvador. Shows that you are on point tonight. So 5, -3. Yeah, that's correct. All right. So then we want to go up 6 units from this point. And so translating it up is literally like taking the point and then lifting it up 6 units.
Mr. Ray.
Yes.
Okay, let me. Why should it be -3? Because it moves on the right. If it was on the left, I think it would have been -3.
It's not. I just want to try to finish this, but it's because that's your X and your Y. Your Y's go up and down. Your X's go left and right.
Yeah, but I'm saying that if you look at the statement, where we have 5 position and 3, but the 3 is -3. How could it be -3? Because we counted on the right.
I'm not sure what you mean, but this is +5 on the x-axis. This is -3 on the y, and that's where they meet.
Okay, +5. Okay.
All right,
plus-
so I just want to try to get a few of these in so you guys can see how it works in the last 2 minutes. So that up 6 units, you're just going to count it up 6 units. 1, 2, 3, 4, 5, 6. And so this is where the 6 units would be. So that's literally 6 units up. It's like saying a bird, you've seen those birds that dive underwater, they catch a fish and they fly back up. Just think of it, the bird went down 3 units, and then the bird has to come back up 6 units to get back to where it was flying. That's literally like the same concept. And so this point would be 5, +3. And if you notice anything about +3 and -3, they are 6 units apart from each other. And if you guys noticed that or not.
Yes.
All right, we got about 1 more minute, and I want to just use that to do number 4. But this is where you want to work on as well. At least try to do some of the points in the workbook. So you remember, finish the problems from page 94 to 97 we didn't touch, and then start page 98 to 101. And that's basically what you're doing. If I wanted to plot the point 40, remember that's x, y. So my x-axis, 4 is right here. My y, 0 is here. And where they meet is literally right there. That's 4, 0. Right? That's literally saying I went 4 units from the origin, and 0 means I didn't go up at all. I'm still on the ground. Does that make
So-
sense?
Yes. Mr. Ray, so that's page 98 to 104 on the workbook, right?
Yes, that's correct.
Okay.
All right, so that's the basic gist of points.
Mr. Ray,
Yes.
for so where they meet all the time, is it gonna be like on the x-axis?
No, they can meet anywhere. So an example is right here. If you have to go, I totally understand. I'll just finish off on this page here because these are pretty straightforward. Notice I skipped number 6 through 8.
I'm gonna leave, Mr. Ray, okay?
No
Wish
problem.
you a
Jacob.
really good Thanksgiving, and thanks for all
Yes.
you for us.
You as well. See you Tuesday, hopefully.
Yes, sir. God
All
willing.
right. All right, so just to show you real quick, anyone who's still left behind, number 9, and remember, you are officially dismissed. Number 9, it says, what are the coordinates of point T? T is here, notice it's not on the x-axis. But if you look at what meets, on the x-axis, that's 4, and on the y-axis, that's -4. And so that
That'll
answer would
be
be
B.
B. Right, if you did number 11, it says, what are the coordinates of point P? Point P is over here. If you look at point P on the x-axis, the x goes first. That's -5 right there. That's correct. What else?
-5.
That's correct. -5, -5. So
Yes.
your choice there would be A. Right, and that's literally how you do any of the points there. The last one up here was point S. Point S is right here. That one's normally challenging for people, but what would that be? Anyone know?
+1.
0.
+1 and
0.
0. That's correct. So that's A. All right, and then they didn't ask this. How about Q? What is the point Q there?
-2 and +2.
-2, +2. That's correct. And how about point R?
-1. -1 and -3.
3.
That's correct. And last one, they didn't give us U. What is the point U?
+4 and +4.
There we go. Once you are able to read the points, now we're going to take, when we come back, is just take that understanding of points and relate it with algebra part. So if you practice 98 to 101, you're going to see more questions like that. You'll see a few challenging ones that are going to bring some algebra in there, but just make sure you have questions for the ones that we didn't cover, 94 to 97.
Is it workbook?
Any homework I give is always from the workbook.
Okay.
Okay, so what are we doing? What pages are we doing for homework this week?
Page 98 to 99, 98 to 101 in the workbook.
Okay, thank
But
you.
you also want to finish any problems I didn't do from 94 to 97.
Okay.
Okay, Mr. Ray.
All right.
Mr.
And
Ray,
any
can I
questions?
ask a question?
Have a nice week. Nice
Yes, you as well,
Thanksgiving.
Gennaro.
Thank you so much.
Good Thanksgiving.
God bless.
Yes, God bless you too.
Okay.
Anyone else? I
Yeah,
thought-
Mr. Ray.
Yes.
For each quadrant of the graphs, is there like a special name? Because I don't know, I think I forgot most of these things, even though I've done
It's
it.
just quadrant 1, quadrant 2, quadrant 3, and
Three.
quadrant 4
Okay, quadrant
in
one.
a counterclockwise direction.
Okay, you said again, anti-clockwise?
Anti-clockwise, so you go the
Okay.
opposite way of the clock.
Okay.
All right.
Anti-clockwise.
Okay.
Yes, you too, Marisol. Have a good night and good Thanksgiving as well.
Okay, thank you, Mr. Ray.
You're
Thank
welcome,
you.
Dorcas.
Yeah.
All right, any other questions before we finish off completely?
No.
All right.
I don't have any, Mr. Ray. Have a good weekend.
Happy Thanksgiving.
Happy
Yes,
Thanksgiving.
thank you as well, Salvador. Thank you, Dorcas. You enjoy your families and enjoy your
Okay.
Thanksgiving weekend.
We'll see you on Tuesday.
Okay. Next
Yes,
Tuesday.
Tuesday to see you guys. Be safe.
Thank you.
Bye.
All right, bye-bye.